Remember that? You shouldn't even come to
If you have fun, oh my gosh. Grades are wrong. Well.
This lecture takes as long as I think it might, then we will just have a work day on Monday. So don't fear. Sorry for making you sit through it, but I'm never going to take your whole hour and then demand that you go home and work. So fair's fair. So I just don't know. I see 5 examples and I think this could take a bit. So let's get to it. So we're finding zeros still, but we're going to now use the skills that we've learned kind of collectively all together. So the first one is going to be f of x equals x cubed plus 7x squared minus 27x plus 19. And I will tell you that x minus 1 is a factor. So let's get to it. Again, the thing on the left is not factorable by using the method that we would use, grouping. So somewhere in there, it's factorable to an extent because there's a factor on the board, x minus 1. But as we learned, we have to do this synthetically. We have to get in and use what we know. That's the purple guy. And then chip it away, like chip away at that stone and then to reveal something else that we can work with from there. So we're going to do the purple numbers here. So we're going to set up our synthetic as 1, 7, negative 27, positive 19, upside down division sign. What number are we going to put outside? Positive 1. Very good. So remember, if it's given to you as a factor, the number that you synthetically substitute is the number that makes the factor equal 0. So let's get to it. This algorithm ought to be pretty quick. And what we're expecting is, of course, again, a 0. If that is not true, then I just wrote a bad problem. So we're expecting that. If it's a factor, by definition, that is what will happen. So step 1, drop the 1, let her rip. Here we go. So 1 times 1 is 1. 7 plus 1 is
8.
1 times 8 is
8.
Negative 27 plus 8 is
Negative.
And 1 times negative 19. Negative 19, which when we add them together gives us, as predicted, the 0. So I alluded to this on Tuesday or Monday, whenever it was, that this would start happening. So that was why we took that 2-day detour into the quadratic formulas, because now we're faced with 3 numbers that don't play nice. So a few days ago, these 3 numbers would have for sure just been a nice little simple baby factoring problem, easy peasy. But now we're faced with 1x squared plus 8x minus 19 equals 0, which is a problem, right? Obviously not factorable, so we go to our backup plan, which is what we've been working on for 2 days, the quadratic formula. And so it's time to get ripping into that. So we're going to find the other zeros. We just have to do it with a little bit of a bigger weapon. We need a bigger tool for this job. So we're going to say that A is 1, B is 8, C is negative 19. And as you'll see, you logically would want to ask this question: was it really ever necessary to write that? No, because like if you know what you're doing, you can look right at the numbers 1, 8, negative 19 and just know that ain't factorable, right? So like writing out the thing that I wrote in red is technically a waste of time, and you're welcome to skip that step. All right. So like once you're committed to the quadratic formula, just get in there and go. All right, let's do this. So our quadratic formula is going to say x equals what first? Negative 8, the opposite of b, plus or minus a big long square root sign, 64. And then we're going to do minus 4 blank blank. And then we're going to divide that whole thing by what number? 2 times 1 is 2. And then we're going to go backfill. and find that our A and C values are 1 and negative 19. What do we know then is going to happen?
It's gonna be bad.
Good job. This really is an addition problem now because the minus and the negative, they're going to find each other eventually. Just get it done now. And let's get into what the math is. So what it's going to actually be inside the discriminant here is 64 plus, and then what's 4 times 19? 76. Good. So we can head to the next step, and this is where we get a good look at it and decide, do we need to go further or are we done? So let's take a peek at what we get. So we get -8 plus or minus the square root of, I believe that's 140, all divided by 2. So the reason we've been practicing the quadratic formula is so that we, can work out the kinks. And what can you tell me about 140? I know 140 is not, it's not on your cheat sheet, that thing, because it only goes up to 100. So either you have really good basic skills, like you can do a lot of math in your head, or you just sit there with a calculator and you start testing 140 to see what it could be divided by. You will find something, FYI. So I'll write it over here. For you guys who continue to refuse, I've seen at least a half a dozen examples in the last couple of days of the harm that comes from people just writing numbers. You have figured out that 4 and 35, right, make 140. You figured that out. The harm comes from not following directions. And I just have pieces of evidence time and time and time again of why I teach this, why math teachers teach this the way we do. Don't do the math until you draw the blank square roots. Because what I keep seeing is people putting 4 root 35. And I can't fix that. Like, you need to follow directions. It's root 4 root 35, which becomes what? 2 root 35. And the people that refuse to do that step with the little yellow arrows pointing at it are the same knuckleheads that write things like 4 root 35. So I would never ask you to do anything if I didn't think it was in your best interest. So putting the blank roots first is a swell idea. Yeah, man.
How does the 4 become 2?
Because the square root of 4 just equals 2. Got it? Sure. Okay. So I'm going to go replace the square root of 140 with what we just came up with. And our answer in its current state is -8 plus or minus 2 roots of 35, all divided by 2. And does the Dorito take effect, or is it pointless? It does. It has a very specific purpose. All 3 numbers in that triangle can be divided by 2, leaving us with a final answer, bless you, of x equals what?
-4 square root of 35.
Perfect. And remember, when things become ones, if they're in either of these 2 locations with the white arrows, those are unnecessary ones. The only one you would ever need is where the -8 is. He's a placeholder. So we're going to state our final answer, going all the way back to the beginning. We're going to state now our answer. The finality of it is to say, here we go. Here are the zeros. They are x equals 1. We knew that one because someone gave it to us, right? And then the other answers are x equals -4 plus or minus the square root of 35. How many answers do you see in this red box?
2.
Nope.
Oh, 3.
There are 3. Sorry. So in the red box, there are 3 answers. There's 1, and there's the -4 plus root 35, and then there's the -4 minus root 35. And we expected 3 zeros because, going back to something we discussed quite a ways back, remember that initially it was a 3rd degree polynomial, so we're expecting to find 3 answers, and we did. Okay. Let's go again, round 2. Any questions about that? All right, let's do f of x equals 7 x to the 3rd plus 11x squared minus 31x minus 3. And again, if this is all we knew, then we would be out of luck until next week when I teach you the rational root theorem. There is a way to try to get in and predict what the potential zeros might be. And I'll show you that next week. But in the absence of that, we do need a little push. We need a little shove. So we're not just sitting here guessing numbers like a bunch of monkeys. So I'll just tell you in this case that f of -3 equals 0. So there's our freebie. That's kind of the theme of the week, is give me one freebie and I can go from there. And so we're ready to begin. And we're going to, again, use the freebie to chip away. So our synthetic numbers are going to be 7, 11, -31, and -3. And then build your upside down division sign. And the number outside will be what? Yeah, just straight up -3, right? It's given to us as a 0, we take it and don't do a thing, just use it. If it's given to us as a factor, we switch the sign and run from there. So we're expecting a 0, might as well just put it in right now, just kind of work towards it. And here we go. Drop the 7. What's my first answer up here? 11 plus -21. 3 times -3 times -10 is 30. -31 plus 30. -1, -3 times -1. And as expected, we get our 0. So great. And again, we're faced with numbers that I think you probably don't need to monkey with too much to see that this isn't going to end well. Like, if you factor enough quadratics, you just know that 7, -10, and -1, it ain't going to happen. You could get in and try it if you wanted to see if factoring works, but in this case, I think it's pretty obvious that it's not going to. So I'm gonna not write the quadratic. I'm just going to go and use these 3 numbers now in my quadratic formula. Just hop right in. Let's go. So we know who A, B, and C are because they're in the red circles. So let's do this. X equals what? 10. Plus or minus, big long square root sign. First in the square root, 100 minus 4 times a couple of numbers, all divided by 14. Good. And again, if you do this with me, I'm just always like going to go back. I'm going to skip those parentheses every time. So just so you know. Now I'm going to go back, reset my brain. And in the 2 blanks, I'm going to put A and C. And that's 7 and -1. Again, what does that mean? Switch into plus. So the discriminant is, again, an addition problem. It really just winds up being 100 plus 28, huh? So our current state, this current state of our answer is 10 plus or minus the square root of 128, all divided by 14. So what we need to do now as a group, if we work together, this won't take as long, is we need to collectively figure out how to break down the square root of 128. I'll have a sip of coffee while you guys mess with that.
Give me the 5 and 4. 32.
You could use 4 and 32, but your experience with math tells you that 32 still has meat on the bone. And remember that if we use 2 numbers where the second number still has meat on the bone, then that means that our first number was too weak. So yes, 4 and 32 would work, but it'll leave you needing to do more. I never want these to take more than 1 step. Go bigger. There's a much bigger square rootable number that goes into 128. 16 also works. I believe it's, what is that? 16 times 8. Again, that's great, but 8 still has meat on the bone. So we're finding all these rad numbers that go into 128, but we still haven't found the best one. I'm not going to write it down until we find the best one. But I will do this. Follow my own directions and put my blank square root signs. There it is. 64 times 2. 64 times 2 is the best and only way I would want to ever do this, because then I know I don't have to do multiple steps. 64 is the hugest number you can use to find progress. And what is the square root of 64? What Kaysen just said is not wrong. And we all have those moments where we say, why didn't I? And that's how you learn math, is you just, through experience, you say, I really should have just divided that dumb number by 2 in the first place. And I probably told you this back in Algebra 1, that sometimes the best course of action with bigger numbers is just to try something stupid like divide by 2 or divide by 3. And it's not because we're interested in the 2 or the 3, but sometimes dividing by little baby numbers produces a really big, interesting number. So you learn from stuff like this and say, maybe in the future, I'll try just dividing by 2. Like, I don't care about 2, but I care about the other number. Yeah. So what is root 64? So this turns into 8 roots of 2. And again, we're going to go back and right where this little white arrow is pointing up here, we're going to change that into 8 roots of 2. And the current state of our answer then is 10 plus or minus 8 roots of 2, all divided by 14. And the Dorito definitely kicks in again here. What can all those numbers be divided by? 2. And so the state of affairs is like, we're about there, we're done. So the freebie was -3. It's up there at the top of the TV. So we can now make a statement of finality and say, here are my zeros. Their names are x equals -3 and x equals 5 plus or minus 4 roots of 2 over 7. And I'll ask you again, how many numbers are in the red box? 3. There are 3 answers in the red box. One of them is -3. One of them is 5 plus 4 root 2 over 7. And the other is 5 minus root 4 over 7. So all answers present and accounted for. I do not have 3 more examples that are exactly the same. So there's a little bit of different flavor in each of these to come. So I do have 3 more. But I feel like at this point, you get the idea, right? You know where we're headed now is, yeah, we synthetically do our thing, but then there's going to be a little bit more going on in the subsequent steps. So for our next example, we have the function -5, x to the 4th plus 19, x to the 3rd plus 14, x squared minus 40x. You know, when I wrote this problem, I 100% prepared that I'm going to hear some, by the way, here, let me give you your freebie. You want your freebie? X minus 4 is a factor. But I've never asked you a problem like this before, so I'm curious to see if anyone catches it. What else? That's actually going to wind up not being true, and that may not make any sense, but what are we missing? You can pull out a GCF. And so just like we have before, we want to skim any free stuff off the surface that we can. And in a case like this, what I'm going to do is, great job back there. Good identification. I notice, and you now know to look for this, you notice that all of those terms could be divided by -x. The negative is because we know that we never want to start problems. If we're going to go down factoring road, we don't want to go there with negatives where they shouldn't be. So what we're going to do is we're actually going to pull a -x off to the side. You with me? And that's going to change the actual math problem. It's going to knock it down now to what? What's the first term? Good job. 5x cubed.
19
Good job.
minus 14.
Good job again. And excellent job. And you now see that actually we don't have to add a 0 because there really wasn't a missing term as much as there was just a GCF that was kind of gumming up the works. So what we're going to do is we're going to take -x and just put it in timeout. And now we're going to do our synthetic stuff on the new problem, the one that's in parentheses. So there will be times when you have to pull a little bit off the surface to expose what we really want to be doing. That's a pretty common theme these days, the whole GCF thing. So it's time to do our synthetic division. So we're going to take our purple numbers are 5, -19, -14, and 40. And what number am I going to put outside? +4. Everybody good? All right, so let's do it. We know what we're expecting. Listen, if I told you that it was a factor of this, newsflash, it's also a factor of this. So like factors don't stop existing just because we've modified the landscape a little bit. Like if it's meant to be a factor, it'll be a factor in the first step or the second step. It doesn't matter. So we're expecting a 0. Let's see if it happens. So same old, drop the 5, and here we go. What's 4 times 5? 20. -19 plus 20 is 1. 4 times 1 is -14 plus 4. And as expected, negative 40 gives us our 0. So the new twist to this problem was that I want you to now be aware that GCFs are back in play. So that'll be the case in this one, and it'll be the case in one more of our examples to come. So let's finish this off and make it official. So again, I don't really think that there's any need. If you wanted to get in and try to factor this, you could, but I'm just going to bypass that. It ain't going to happen. So these are our A, B, and C values. It's a quadratic, right? The quadratic formula works once you're down to 3 numbers. 3 numbers make a quadratic. So let's begin. X equals what? Negative 1 plus or minus. All divided by. Nice. And then when we backfill the blanks, what do we put in there?
5.
5 and 10.
And negative 10. And for the third straight time, we're going to switch to addition. So the discriminant is actually just 1 plus what? What's 4 times 5? 4 times 5 is 20, and 20 times 10 is 200. So it's really 1 plus 200. And so the current state of affairs is x equals negative 1 plus or minus the square root of 201 divided by 10. So if we divide and conquer here and we sit around with our calculators and try dividing things. So what you should do is grab your calculator and start dividing maniacally by things like, first off, don't waste your time with any evens, right? Don't try dividing by 4. No offense, but that's pretty stupid. Like anything that's odd, you can't divide by 4. Same for 16, right? For 36. So let's focus on odd squares like 9. Can 201 be divided by 9? Okay, and again, I would say don't waste your time with 25. That's pretty dumb because it ends in a 1. Things that, right? Say again? Right, so 3 times 67 is pretty rad, huh? But do we care? Why not? Because neither of them are on the red list. Neither one of them is square rootable, right? You can't square root of 3 and you can't square root of 67. But what's good about that news is that while it may be useless on the surface, it's really not, because 67 is dead. And if 3's dead and 67's dead, guess what that means? It means 201 is dead. So this is one of those where the root is actually just already dead. So there's no Dorito here because the 201, it ain't happening, right? You could divide by the other odd squares, like 49 seems like a reasonable candidate. Try dividing it by 49, you go, that didn't work. And then you get to a point where you realize, okay, this isn't going to happen anymore. Like you start dividing by bigger odd squares. The next one you got to jump to is like, what, 81? And then you realize, yeah, this doesn't work. So we're ready to state our answers now. And I'm going to see if you catch it. Going into this problem, hint, hint, follow the big fat yellow circle. How many answers are we expecting? Very good. Let's make sure that we have 4 answers present and accounted for. So who wants to think or state what they think the first answer is? X minus 4 is not a 0. 4 is a 0. I will accept that. Give me more. You're on a roll back there today. You're really checking some important boxes today. That was the one I was worried you guys wouldn't catch, was x equals 0. And remember that just like has always been the case, if I pull out a GCF and my GCF is just a number, it's trash. But if my GCF has a variable in it, then it always produces a 0. Sometimes more than 1, but in this case, only 1, because we only pulled out 1x. Great catch back there, Stesha. And now we can find the other 2 answers. They're written in purple over here. So our answers are 4, 0, and negative 1 plus or minus the square root of 201 all over 10. 4 answers present and accounted for. Got it? All right. Round 4. And your freebie this time is that f of negative 2. You guessed it, equals 0. Now you know, right, to look for a GCF, and there isn't one. The one in front of the x to the fourth says there's not going to be a numerical GCF, and then the fact that the back term doesn't have an x, we just wipe it clean. There's no GCF, so we can go right in. And this is, I think, a little bit different for us because this polynomial has 5 terms. We're not really accustomed to this, hence its appearance in our notes today. So this will be a little bit of a new experience. Let's get right in and put our purple numbers. So they are in the fronts of these right here. Right. So we're going to have a 1, a 5, a 2, a -20, and a -24. And we're going to upside down synthetically divide or substitute what number? And we go. Again, if you're into this kind of thing, I don't know if you guys do what I do or not, but putting the 0 is just kind of a target, something to shoot for. So here we go. Boom. What's -2 times 1? 5 plus -2. -2 times 3. 2 plus -6. -2 times -4. +8. -20 plus 8. -12. -2 times -12. And there's our 0. Kind of a foregone conclusion. But what's interesting this time is that we have 4 numbers that survive. This is not a quadratic. This is a cubic. So these numbers, these 4 numbers that I'm pointing out with the red arrow, they are the coefficients of a cubic. Remember, synthetic division always knocks one level down. So if you start with to the 4th power, synthetic will produce something to the 3rd power. So these numbers represent 1x to the 3rd plus 3x squared minus 4x minus 12.
Yeah.
So we have to do what? I would say yes, but the problem is we don't have any more freebies. I don't disagree, and there's going to come a day next week where, yes, we will just keep smacking a problem with synthetic division. We're just not there yet because we don't know anything else. But we do recognize the red thing. We should. What is it? It's a grouping problem. Very good. And so grouping rears its ugly head again, and we realize, wait a second, I may not be able to use the quadratic formula, but I do have a tool for factoring 4th degree polynomials, and gee, I hope it works. So let's draw our little wall down the middle, and let's get in here and see if we can make some progress. Grouping to the rescue. What's the GCF of the first 2? Leaving behind what? Plus 3. And we drop down the minus, and what can we get out of the second 2? Leaving behind. X, change the sign, 3. And then the current state of our factors is we have an x squared minus 4, and we have an x plus 3. And that equals 0. And we still don't have enough really just explicitly to state the zeros, but we're almost there. What do we see? I see a difference of 2 squares. You do too. I see an x plus 2. I see an x minus 2. I see an x plus 3. And now I can pop out of this 3 answers. How many were we expecting from the beginning? 4. And we've already got one present and accounted for, probably about 3 inches up on your paper. You remember that guy that we had. So don't lose track of him. But these yellow and white parentheses are going to produce the other 3. So let's go in and make a list. So what do we get from that guy? -2. What do we get from this guy? X equals 2. What do we get from this guy? And then who was our freebie at the very beginning? -2. I'm trying to make sure, is that what we had synthetically? Very good. So we actually had an early -2. So if you wanted to, instead of writing it out twice, we could just write x equals -2. And then what, you remember what we put right next to the x equals -2? Not squared, but a little times 2 for multiplicity. Could we graph this? We could. I'm not going to ask you to, but we totally could. We know there'd be a bounce root at -2. Yeah, we could totally do it. And then the last example is the fifth. Are you feeling okay so far? Okay. Again, what's going to change next week is at some point then the bottom falls out and I stop giving you freebies. And then this huge thing called, I'm going to say it again, it's called the rational root theorem. It comes to your rescue and it's really quite a chore. But there's a way to look at a polynomial, and what you wouldn't want to do, like imagine, well, here, take this problem for example. Let's just do the next one. And then I'll talk to you about what a pain this would be without the rational root theorem. 6x to the 6th minus 29x to the 5th minus 20x to the 4th plus 75x cubed. And that's it. And then I will tell you in this one that f of 5 is 0. Where do we start? Nice work. So remember to watch for the GCF. We've had 5 examples now. This is the 5th one. And in 2 of the 5, GCF has been a thing. So who knows? But sometimes it's there, sometimes it's not. But if you miss it, oh boy, big trouble. What's the GCF? X to the 3rd is the best we're going to do. So I'm going to take an x to the 3rd and I'm going to put it in a little bit of a timeout. And then I'm going to rewrite the polynomial with the x to the 3rd having been pulled out. So what's the first term going to be? Minus. And again, there really aren't any missing terms. It looked like it at the beginning, but it was just the result of the GCF, being a little turd. So let's dive in. So we're going to use the coefficients of what's in here to set up our synthetic, and they are 6, negative 29, negative 20, and 75. And then we're going to do that. And what number are we going to put outside? Regular old 5. And if you do this, then put your 0 and just work towards it. And we begin. Drop the 6 and we're off. 5 times 6, negative 29 plus 30. 5 times 1, negative 20 plus 5. 5 times negative 15. And there's our 0. This is, again, where you always have a choice to make. And the choice is, do I want to get in there and factor, try, or do I want to just say screw it and use the quadratic formula? You guys decide. Okay, great. I'll decide for you. Let's go ahead and just do the quadratic formula. So we're going to use these 3 numbers. I mean, some people really like factoring and they might actually endeavor to get in there and try, 6x, 1x, 3x, 2x, one's a plus, one's a minus. That's your thing. But anyways, let's go ahead and hit the QF. X equals what? Negative 1 plus or minus 1. All over 12. And then the blanks go. So I think we have another plus, right? The reason you keep seeing so many pluses is because I'm not putting imaginary answers in yet. I don't know if you remember this at all from our past together. I don't even know if it's ever come up, quite frankly, because I don't think we talked about it this year. Do you guys remember what happens if you get a negative number inside of a square root?
I don't know.
Yeah, it's imaginary. And so we'll talk about that. But if it feels like there's a lot of these where it's turning to plus, that's because I'm not putting problems in where you get, when you do your b squared minus 4ac, I don't want it to come out negative yet. So that's why a plus happens a lot, because I want to make sure you get positive numbers. So that's pretty common right now. So this is really just a glorified addition problem, and it's just going to be 1 plus some. I would do it in a different order because I like doing math in my head, because I don't know what 24 times 15 is, but I do know that 6 times 15 is 90 and 90 times 4 is 360. So I like doing it in that order. If I can find a different order to multiply numbers in to keep it mental, that's what I like to do. But you just use a calculator, I don't care. So the current state of affairs is negative 1 plus or minus the square root of 361. Oh my gosh, over 12. Any help on that one? Find it? It's not a dead root. In fact, it's the exact polar opposite of a dead root.
Yeah, it's 19.
Was wondering if you guys would look at your resource sheet, because right there, if you look at your sheet that has all the square roots on it, you know, the one you've been using, it has the square roots, cube roots, fourth roots, all that stuff. Right there next to the last spot, you'll see the square root of 361 and it equals 19. So rather than sit there and try to divide by, 9 and 20 or whatever, sometimes you have an aha moment and you go, man, I should have just tried to take the square root of it in the first place, because that can happen. Bigger numbers are hard to spot. If it was like a 25, you're like, well, duh. But a 361, who knows the square of 361 off the top of their head, right? Not normal people. So it pays dividends sometimes just to say, I'm going to try it just for shiggles. I'm just going to say, maybe it's just square rootable right out of the gate. And it is. So because the square root of 361 just equals 19, this is going to become a pathway problem. Turns out this thing in the big purple egg, it could have been factored had you wanted to go down that road, FYI. But now that we're committed to this, why go back and factor it now? That seems silly. So our answer in its current state is x equals -1 plus or minus 19 all over 12. And now this is where we traverse the two different paths. And the first path has a name. His name is plus. What's -1 plus 19? So one of our answers is 18 over 12, which if we divide those both by 6 is 3 over 2. The other answer is obtained by taking the other road, the minus road. What's -1 minus 19? So one of our answers is -20 over 12. Divide those both by 4, what do you get? -5 over 3. What you take from this, if you're a math nerd, you'll appreciate this. What you take from this is that 2x minus 3 was a factor. And what you'll take from this is that 3x plus 5 was the other factor. So back here 5 minutes ago, when I was talking about this thing in the big yellow oval and saying factor it if you want to, I was wondering if anyone would kind of take the bait there and run with it. But it turns out that if you're good at factoring, that might have been a quicker pathway for you, because sometimes factoring actually works, right? So just be aware of that. So when we make a list of our answers, we should have, holy smokes, guys, we should have 6 of them. Wow.
We still have the X cube.
What is that going to give us? Bingo. So we got a lot of our zeros out of the way with that huge Mongo GCF. When we pulled out a GCF of XXX, we pulled out a boatload of stuff. We got 3 of our zeros off our to-do list just like in 2 seconds. So to make our list of answers, let's get to it. We're going to say first off that x does equal 0. We knew that right away. And then we're going to put that little parenthetical comment next to it and say not cubed, but times 3. Remember, that means there's 3 of those bad boys. Give me another 0. Yeah, 5 was the freebie. So let's take that one and run with it. So we can also say that x equals 5. So we've got 4 answers right now. We need 2 more. Where are they? One of them is in the top there, x equals 3 over 2. And then the last one is, yeah. And there they are. 1, 2, 3, 4, 5, 6. All answers accounted for. So yeah, I figured that'd take about the whole hour. We got about 4 minutes. I'm not even going to bother just to give you the assignment. I'm just going to give you the rest of the hour off. The Monday will be just a full-blown work day. I have a PDF. I'm not even going to post it today. I'll just post it before class on Monday so we can just get going on it. Sound good? Don't forget that, if you have any issues that you need to take up with me, like missing quizzes or quizzes that you need to come in and go over some stuff, if you need help with anything, there's Friday school tomorrow. There's no teacher stuff getting in the way tomorrow. Tomorrow is I'm all yours from 8 to 10. So if you need anything, make it happen. You can always come in for lunch. Remember that I'm gonna end this because no one on the recording wants to hear all my jibber jabber.